Assalamualaikum warahmatullahi wabarakatuh. So, so we have discussed the theoretical behind the equation of motion for translation for both rectilinear motion and curvilinear motion. So we have a problems here. Problems. This is a rectilinear motion. So we have a car which has a mass of two megagram and the center of mass at G. You see that for these problems, everything is given. G is in the middle, somewhere here. I mean, the distance and everything. And determine the car's acceleration. The car's acceleration. Extracts all information. You have to find what? Ag lah. You have to find Ag. If the driving wheels in the back are always slipping, the backs, the wheels in the backs are always slipping. When always slipping, what happens? Slipping means that there's a friction. Okay. Whereas, whereas the front wheel freely rotate. This one free means that this one freely rotate. This one doesn't rotate. Doesn't rotate. It's just sleeping. Neglect the mass of the wheels. The coefficient of kinetic friction between the wheels and the road is 0.25. So, what is your mind now? First, this is a translational motion, rectilinear motion. So you have summation of f x ma gx. Summation of f in y is ma g y. And of course, the summation of moment at g for the example is 0 because the car doesn't rotate. The car doesn't rotate. That's why it doesn't has the value of uh, I alpha because alpha is 0. Okay. Now what you have to do? Basically, before you solve this problem using these three equations, it is better to draw as you did in statics. You have to draw FBD, free body diagram, and for dynamic problems, you have to add or to draw one more diagram, which is kinetic diagram, or I put it KD. FBD and KD. What's the difference? It's easy to remember this one, class. So you have F equal to MA, right? And summation of moment is I not alpha. So everything on left hand side is FBD, and everything on right hand side is you draw in kinetic diagram. Alright, for these figures, we have you just draw like a box. You don't need to draw the exact one. You have a wheel here. G is here. So you have weight. You have weight. Weight is given for mass is given for 2 megagram or 2000 kilogram. 2000 kilogram. It means that 2 megagram is 2000 kilogram. So you have weight 1000. Alright. F, this is the weight. What else do you have? Okay. We have a normal force at A. Yes, because it's touched on the floor. So you have normal force at B. And at the same time, you have friction force. I put it F. Okay. The distance is given. The distance is given from here to here is what? Is 1.25 meters. Here to here is 0.75. Alright, so this one G. And here G to B and A in Y direction is 0.3 meters. This one is 0.3 meters. Okay, and then this is the dimension is not compulsory in FBD. The most important thing is the forces or moment, and A and B, FB and the weight. And you draw kinetic diagram. So of course this car accelerate to the right. So this one G, draw A G in X, because this car doesn't have a motion in Y, because you have the floor. How come it goes down or goes up? This is a car. Okay, so you have to uh, solve it using the summation of F. First we solve in X. We look in X. So you have to choose either to the right is positive or to the left is positive. It's up to you. If you choose to the right is positive, it's okay. So anything to the right is positive. Okay. So it's equal to M. So it's equal to M A G X. Okay. But bear in mind that the positive, to the right is positive, not only belong to F, not referring to F only, but refers to A as well. Okay, the positive sign to the right. So you can say that it gives you have you know the friction force FB to the left. To the left is negative. Then it's equal to what else? Yeah, sorry, you plus what? There's only one force acting in X direction. This one positive, this one negative. Okay, this one positive. Okay, so negative. Okay, so there's only one force acting in X direction. So you will have negative FB is equal to M A G X. But A here, this car accelerate to the left. So here should be negative. Okay, negative. So FB is equal to, we know that FB is mu K times NB. Negative mu K times NB is equal to negative 200 kilograms times AGX. Mu K is 0.25. Okay, so you know this value, you don't know this value, you know this value, but you don't know this value. You still cannot solve this problem because you have two unknowns and you have one unknowns. Okay, sorry, two knowns. Sorry, you have two unknowns in one equation, so you cannot solve it. So you have to come up with another one, summation of force in Y. Let's say uh to upward is positive. Okay, M A G Y. Okay, and of course this AGY is 0 because it doesn't have a acceleration in Y. So you will have what? NA. So you have NA plus NB, okay, NB minus W, minus 2000 times 9.81 is equal to 0. So here you can see that you have one equation. Okay, you have two equations, 1 and 2. You can see here that, do you think that you can solve this problem? Not yet, because you have two unknown, sorry, three unknown here, 1, 2, and the third one, and a. But you have three equations, so it's two equations, you cannot solve it. In order for you to solve a simultaneous equation, you must have at least, the number of unknown is equal to the number of equation. uh, at least, or you can have a less unknown than equation, the number of equation. Okay, okay, we solve it. Okay, so I write down here, uh, um, I write down again the equation, minus 0.25 and b is equal to 2000 times a g x. We also have an a plus n b minus 2000 times 9.81 is equal to 0. Okay, we still need one more equation so that it's come where the equation for moments comes in. You will have the summation of moment at g is I g alpha. Okay, first, by using this equation, we use this equation first. Okay, so summation of moment, what's any forces acting on these bodies, or on the car, it will create a moment. It will create a moment, but the summation might be 0, depend on either this one is rotate or not. Of course, the summation of moment here is 0 because we know that the car doesn't rotate. So let's say that counterclockwise is positive. The summation of moment at g is equal to what? We know that alpha is 0 because the car doesn't rotate. So this one is equal to 0. Okay. So what we have here, you can see that NB. NB, the force NB, eh, you have to, because we are referring at point G. So you can imagine then how this force acting on by fixing at point G. So it will goes like this, correct? It will create this kind of moment. So it will create a counterclockwise moment. So you have to know that you draw a straight line here and draw a perpendicular line to G. This is a distance R. So R here is 0.75. So you will have, for the example, RP times F, sorry, times NB. Clockwise is positive, counterclockwise positive, okay. Then you have another one, yeah. But this one create a clockwise, clockwise moment, okay, because your G is on the right. So the distance here to here is 1.25. Okay, negative RA 1, NA. Okay, what else? We still have FB. FB will create a, because you are referring to point G, it will create what we call it clockwise motion, clockwise moment. So this one is negative, negative, and the distance is 0.3. Okay, 0.3. So minus RFB times FB is equal to 0. Substitute the values. This one 0.75 times MB minus 1.1.5 and A minus 0.3 FB. FB is what? FB is 0.425 times NB. 25 and this one equal to 0. You can see that now now you have how many unknowns? You have one unknown, two unknown, all right, third unknown, third unknown as well, but we have counted it and B. What else? So the third equation, yeah, same unknown and A and the same unknown and B. So you have three unknown, you have three equation so that you can solve it. Okay, the answers for this one is you can solve it by yourself lah. I don't want to waste my time to solve this one, but the answer is AG in X is 1.59 meter per second square and A is 6.88 and NB is 12.7 kilometer. All right. Okay, now, we have discussed by taking the value of moment at G. As we discussed before, we can take any point on these figures, on this car, to be used as a point uh, of moments, where we calculate the moment. We can take, for the example, summation of moment at A is equal to what? Summation of moment due to kinetic at A. Or you can take that any point somewhere else. Let's say summation of moment at B, for the example. Okay, kinetics at B. Eh? Let's take the first one. So you will have summation of moment counterclockwise is positive. Okay, I draw it back. I will draw it somewhere here. So I just draw it on sorry. Okay, I draw straight away on this one. We have an A. Okay, we have an B. We have FB. Okay, and then I draw the kinetic diagram on the same figures. This one is AGX. Okay, summation of moment at A. We are referring to this point. And okay, you got one more. W. W. So here, if you choose a point A as your reference, so now it's not become 0. It's become the kinetic of element at point A as well. For the example, what's the force? Of course, on the right is at the moment. So NA, okay, NA is a clockwise. Clockwise, it will create a clockwise moment. Sorry, sorry, sorry. Okay, now you are referring to point A. You are referring to point A. So any forces acting directly to point A is not counted. For the example, NA. Of course, NA is not counted because it goes directly to point A, or any forces come up from point A, or goes any forces cross point A is not counted in calculating the moment. For example, NA. NA cross point A. Of course, it doesn't count it. So, what's the force counted? Is NB, W, and how about FB? You can see the FB, if you draw a straight line, FB cross point A, correct? Because it's parallel. It's not parallel, it's serial with A. Point B is serial with point A. So that's why the FB is cross point A. So FB is not counted in calculating the moment. So what left? So we will have NB times the radius, means that B to A. Now B to A, because you refer to point A, which is 2 meters. 2 meters. And this one is clockwise. Counterclockwise is positive. What else? Weight. Weight is downward, so it create a it will create a clockwise moment. So it will give you negative W times 1.25. G to A is, you draw a straight line here. G to A is 1.25. And then on your right hand side, summation of moment due to the kinetics, which is acceleration. So it will give you M, the radius is 0.3, and it will create a counterclockwise, so it's positive 0.3 M. You must put the M, mass AG. So instead of using this equation number 3, you can choose equation number 4. Okay. Alright. Okay. So instead of 4, you can use B as well. So anything at B, any forces cross point B or come out from point B is not counted. So summation of moment at B, B. So only two forces involved, W and A. So NA will create, referring to point B, it will give you a clockwise moment. So it will give you negative. The distance is 2 meters times NA. Now referring to point B, weight become counterclockwise. So it's positive. The distance is 0.75 times W. And this one equal to, okay, this one will create a counterclockwise as well. And the distance remains 0.3 times M times AGX. This is the equation number 5. Alright. So you can solve this one. You can solve this one either you can use equation number 1, 2, or 3, or equation number 1, 2, 4, equation number 1, 2, or 5. If you choose either, or you solve this one, the problem using these 3 equation, 3 different set of combination of equation, you will get the same answers. All right, thank you very much. So this is the first example of what we call it, equation of motion for translation. We will have one more, so I will upload it once I finish recording the videos. Thank you very much.